So let's start our lecture today. So last time we are left with the lattice calculation where last time. So we are trying to calculate the sum of so analyze the sum. From 1 to infinity of summation L from 1 to infinity of summation J equal to L minus 1 times K plus 1 to K minus 1 where the summand is NK squared minus J squared over B squared NK times NK squared plus J squared. And then on the graph, so we have that. So the vertical one is the J's, right? And then so the horizontal one is the N's. And then we have so these are the points that we counted, and then so here like at the kth position, it's being omitted here, and then continue counting, and then count, and then 2k is omitted, and then we have the pattern here. Okay. So let's so in order to evaluate this one, so let me think. So we need a method, right? So shall we just use the like the L method, like the barrier sum, or okay. So if the J do appear on the case, then if you sum over all the n's, if J appear on the case column, right? So I'm thinking of like doing like a review or something. So if the J appears on the case column, so then yeah, so then this is like J is equal to K. So the NK will be cancelled out. let's see. So on the let me break this break everything into like the barrier here. So basically, what we do here is that we focus on like points that lies on like the same barrier. So namely the distance. So either like the horizontal distance is exactly equal to this L, right? And then so on the barrier L. So namely, so namely these are all the points. So either like L, LM, and also like union like LM where M from 1 through L, and then like NL, right? And then N is in 1 through L. Yeah, so so these are the points that like horizontally it has a vertical distance L, and like horizontally, so vertically has distance L to the first line, and then also like the same thing for the horizontal, like the horizontal one, and also the let me think. So if let's say L is less than K, then so everything should be sum in this scenario. So so then let's use the letter sum over L. Okay. So we sum over the points on this barrier, so which is equal to so we first sums over the horizontal line, or like the horizontal the row, like horizontal direction. So where I'm using the index. Let's use the index. So which index should I use? So n, I'm using n as the index. So for example, 1. So basically, I'm having n from 1 to L minus 1, and then so I'm having so this is like so when we are summing the horizontal, right? So the vertical the y value is being fixed, right? So the y value is always equal to L. So where the y value is actually the m value, so it's like nk squared minus L squared over so b squared times nk squared plus L squared, and then plus in this scenario, so we are summing over the vertical one, right? So for the vertical one, I'm using n from 1 to L minus 1, and then I'm fixing n to be equal to L, so Lk squared minus, so now I'm having the m squared over b squared times Lk squared plus m squared and then so the remainder is, so I have to also sum the corner point. So for the corner point, what I have is that, so the corner point should give me the x value and the y value must be equal to L together, right? So n equal to L and n equal to L and j equal to L. So Lk squared minus L squared over b squared times Lk squared plus L squared. So this is equal to so let me forget about the denominator for a while. So let's focus on the numerator first. So for the numerator, so yeah, so again, like we are trying to find like a common denominator, right? So maybe a common lower bound for the denominator. So and then for the numerator, so let's use this one as let me use the letter A maybe. Let me use letter capital A, and then this is capital B. So the numerator for capital A is equal to, so the numerator, so let me use the letter yeah, so maybe let me use the letter the numerator. So I think I used this notation in the past, right? So let me just keep using this one. So here this sum to be denoted as the numerator. So I'm using the letter n for the numerator. So when I sum over this n here, so what I have is that I'm having this one as k squared times so it will be yeah, I have to remember the formula for the square sums. So so it's something like yeah, so let me give me 1 second. So okay, so this is equal to so L minus 1 plus L times L, sorry, times so 2L minus 1, and then so minus, so this is L minus 1 copies, right? So L minus 1 times L squared. Let's see, so and then for the numerator of B, so what we have is that we have the L squared at front, and then, oh sorry, so this is like L squared, L minus 1 times L squared times K squared minus, I'm summing over the M squared. So M squared should give us L minus 1 times L times 2L minus 1. Yes. So when these two are added together, right? So this is equal to so k squared times, so this is equal to L squared minus L, right? And then, so multiply together, I get 2L cubed minus L squared minus 2L squared plus L minus L cubed plus L squared, and then this is equal to so I have L cubed minus L squared times k squared, and then so this is equal to minus so I think same thing here, right? So L squared minus L. So I get yeah, so 2L cubed minus L squared minus 2L squared plus L. So finally, so when we sum over all of them, so let me just distribute the value in. So 2k squared L cubed minus k squared L squared minus 2k squared L squared plus k squared L minus. So let me just sum over this one. So this A and the numerator for A and the numerator for B. So and then minus L cubed plus L squared, and then this is plus L cubed k squared minus L squared k squared minus 2L cubed minus, sorry, plus L squared minus 2, oh sorry, it should be plus 2L squared minus L. So so for L cubed, what I get is that I'm getting, this is L cubed here, and then I get this L cubed here, and then I get this one here, and also this one here, and yes. So what I have is that I'm having so 2k squared minus 1 plus k squared minus 2 L cubed. Okay, so sorry, minus. Then I have so plus minus k squared. So minus 3, yes. 3k squared. So combine these two. Oops. So L squared. So plus 1 is 1, and minus k squared. So this one and plus 1. Oh, sorry, this should be plus 3, right? L squared. And then, so for the L term, so plus k squared, and minus 1 L. So And also for the denominator here, yeah, so let me see the timing here. So okay, yeah, I'll see. Because yeah, because of the time issue, I have to stop here today. So yeah, so let me continue analyze next time.